So welcome you back to our lecture series on control systems. Today in our lecture we are going to discuss about the signal flow graph. So in our earlier lecture we have seen the block diagram reduction technique which is used in order to identify the transfer function. So this signal flow graph, it is yet another pictorial representation, a graphical representation in order to identify the transfer function of a system. The main advantage in our signal flow graph is that now we have a standard formula called as the Mason's gain formula, which we will be discussing later in order to identify the transfer function. So earlier in one of our lecture series, I have discussed regarding the basics of signal flow graph. So today in our series we are going to solve a problem using the signal flow graph. So the step 1 in our signal flow graph is to identify the forward paths. So what is a forward path? A forward path is nothing but the signal which is starting from the input and it has to end at the output. We call it as the forward path, and it has to travel each node only once. So all these 1, 2, 3, they are all called nodes. So for any reference, please refer to my earlier video. So the first step is to identify the number of forward paths. So this is one forward path. So I am just writing over here. So this is the first forward path, 1, 2, 3, 4, 5 and 6. So this is my first forward path, G1, G2, G3, G4 and G5. So this is my first forward path. So I will indicate this as P1 now, which is nothing but just multiply all the transfer functions. So I am getting as G1, G2, G3, G4 and G5. So this is my first forward path. So P represents the forward path, 1 represents the first forward path. Similarly, we have another forward path which is nothing but 1, 2, 3 and then it just goes to 5 and then finally 6. So this is my second forward path. So G1, G2, this is G6 and this is G5. So my second forward path, I'll put it as P2, which is nothing but G1, G2, G6 and G5. So the first step is to identify the forward paths. So I'll write the answers over here so that later we can recall. So P1 is G1, G2, G3, G4 and G5, and P2 is nothing but G1, G2, G6 and G5. So here the first forward path, this is step 1, we have completed with step 1. Now step 2. Step 2 is to identify the closed loops. So what do you mean by the closed loop? A loop is nothing but the signal has to start at one node and it has to end at the same node and it has to travel each node only once. I'll repeat. Closed path is nothing but the signal has to travel, should start with one node and it has to end at the same node and it has to travel through each node only once. So we'll just try to identify the forward paths, the closed loops. So we can see here, this is one loop. So the signal is starting from 2, it is traveling, it is coming to 3 and again it is coming to 2. So this is the first closed loop. So I'll just write the closed loop over here. So this is 2, this is 3, H1 and this is G2. This is my first loop. That's the closed loop. So the transfer function for this, I'll write it as P11, which is equal to, it is G2 H1. It is G2 H1. Similarly, the second loop, I'll just write it as, this is my second loop. So it is 3, 4 and now it is G3 and it is H2. So here it is a forward path. So I'll write as P21. So this indicates it is an individual loop. Okay, and 2 it indicates that's the second loop. So here it is G3 H2 and then we have the third loop which is given by, it is 4 and 5. So it is G4 H3. So I'll write as P31 which is G4H3. So we have identified 3 loops and we have one more loop. So I'll just write one more loop. So it is 3, it goes to 5, it comes back to 4, from 4 it goes to 3. So it is 3, 4 and 5. So it is G6, H3, H2. So you can see it is a closed path. The signal travels through each node only once. So this is my 4th loop. My transfer function is P41, which is nothing but G6, H2, H3. So this is the step number 2, which is to identify the individual closed loops. So we had 4, so I'll just write all 4 over here. So it is P11, which is G2H1, P21, which is G3H2, P31, which is G4H3, and P41, which is nothing but G6H2H3. Step number 2. Now step number 4, it is nothing but 2 non-touching loops. Non-touching loops. So here what we are going to do is, we are going to compare 2 loops, and if both the loops does not have a common node, then they are one combination of 2 non-touching loops. So we are going to compare 2 loops, and if those 2 loops, if you don't have a common node, then it is a combination of 2 non-touching loops. So you can see I am just comparing node 1 and node 2. So node 1 and node 2, it is easily identified. See, you have node 3 and you have node 3. So this does not form a non-touching loop because we have node 3 as a common one. Next, I am comparing loop 1 with loop 3. So you can see here it is node 2, node 3, but here it is 4 and 5. So all the nodes are different. So this is one combination of 2 non-touching loops. So I just write over here. Now it is 2, 3. Now it is G2. This is H1, and the next one is 4, 5. And now this is H3, and it is G4. So this is one combination of 2 non-touching loops. So the transfer function will write as P1, 2, which is equal. So this 2 it indicates it is 2 non-touching loops. So you just make a difference. Here it is 1, it indicates individual non-touching loop, 1 non-touching loop. Here it is 2 non-touching loops. Okay. So now I'll write it as, I'll just multiply all. So G2, G4, H1, H3. So this is one combination of 2 non-touching loop. Similarly, I'll take 1 with 4. Now you can see 3 is common, so it is not a combination. Similarly, 2 with 1 already we have seen. 2 with 3, again there are common nodes. 2 with 4, again there are common nodes. So therefore, further we don't have any 2 non-touching loops. We have only one combination of 2 non-touching loops. So my step 3 is completed. And my step 4 is to identify delta. So that is using the Mason's gain formula. In the beginning I have told you we are going to find the transfer function using Mason's gain formula. So that is according to Mason's gain formula. So we have our transfer function which is given by T of S, which is equal to, it is 1 divided by delta summation k pk delta k. Now where this k stands for the number of forward paths, so which we have identified, we have 2 forward paths. So therefore this formula will become 1 divided by delta. So k is equal to 2 in this case. So it is p1 delta 1 plus p2 delta 2. So P1, P2 we have already identified. Now our next step is to identify this delta, where delta is equal to 1 minus sum of the loop gain, that is the individual loop gains, plus it is sum of non-touching loop gains. So this is the formula minus, it just keeps on going. It will just go for 3 non-touching loop, 4 non-touching loop, etc. So this is the formula in order to identify what is delta. Okay, so substituting here I am getting it is 1, there is 1 minus sum of individual loop gains. So loop gains already we have seen, these are our individual loop gains. So it is P11 plus P21 plus P31 plus P41. And then plus sum of non-touching loop gain, already we have seen this is our non-touching loop gain, we have only one, so it is P12. So substituting for P1 and P2, we will get as this is equal to 1 minus P11, which is G2 H1, plus P21, it is G3 H2, plus P31, it is G4 H3, and P4 is G6 H2 H3, plus P12, it is G2 G4 H1 H3. So we have identified what is delta. So we have identified what is delta. Now our immediate next step is to find out what is delta 1 and delta 2. So that is my step 5 to identify what is delta k. So delta k is nothing but it is delta for the forward path, which is not a part of the forward path. So that is nothing but delta k. So in this case what we are supposed to do is, now we have to, so I'll just keep this alone so that it will be useful for us to write in the next step. So our delta 1 is nothing but it is delta for the first forward path. So we had all the loops, loop 1, 2, this is 1, 2, 3 and this is the 4th loop. Now we have to compare all the loop with the first forward path. So our first forward path was 1, 2, 3, 4, 5 and 6. Now we have to identify whether the nodes of the loops, whether they are part of the first forward path. In this case, all the nodes are a part of the first forward path. So therefore our delta is nothing but it is equal to 1. Since there are common nodes of the loops in the first forward path. Similarly, delta 2, it is for the second forward path, where our second forward path is 1, 2, 3, 5 and 6. Again you see all the loops, they will be having their nodes which is a part of the second forward path. Therefore our delta 2 is also equal to 1. So we don't have loops which does not have any common points. So in that case we can simply write it as delta 1 is equal to 1. Actually it is delta for the forward path. So which means I'll get 1 minus sum of loops, individual loops. In this case there are no loops which is not a part of the first forward path. Therefore this is going to be 0. So 1 minus 0 is 1. So that's why I'm just writing it as 1. So that is my next step, that is step number 5. And finally the last step is to find our transfer function T of S using Mason's gain formula. So my T of S is equal to, it is 1 divided by delta. I'll just write it this end. So my T of S is equal to 1 divided by delta. So 1 divided by delta, I'm writing this entire thing is delta. So it is 1 minus G2 H1 minus G3 H2 minus G4 H3 minus G6 H2 H3 plus G2 G4 H1 H3. This is my delta into P1 delta 1 plus P2 delta 2. So delta 1 and delta 2 is equal to 1. So therefore it is P1 plus P2. It is G1, G2, G3, G4, G5 plus my P2 it is G1, G2, G6, G5. So this is my P1 plus P1 delta 1 plus P2 delta 2. So this I will simplify this and I'll write it as T of S is equal to G1, G2, G3, G4, G5 plus G1, G2, G6, G5, the whole thing divided by 1 minus G2 H1 minus G3 H2 minus G4 H3 minus G6 H2 H3 plus G2 G4 H1 H3. So this is my final transfer function for the given signal flow graph. So here in this case, now we have a standard Mason's gain formula which is used to identify the given transfer function. So the next class, now we will discuss how to convert a block diagram into a signal flow graph, thereby identifying the transfer function. So meet you in my next lecture. Thank you very much.